As all of you know that in the last class I discussed the formation of ions, that is how are cations and anions formed. In this class I will show you how cations and anions combine with each other and form compounds. So before discussing that very thing, I would like to tell you some points about compounds. What are compounds? So you know that compounds are the chemical substances that are formed by the reaction between two or more than two substances. That is, if A plus B they react with each other, they form AB. So these are the elements which are called as reactants, and this is a compound, and the new substance that is formed, that is called as product. You know that. So compounds are formed when two or more than two chemical substances react with each other, and the chemical substances may be element and element, compound and compound, or an element and a compound, and the new substance that is formed is called as compound. So how are these compounds formed? How many types of compounds are there? There are two main types of compounds. One is ionic compound and second is covalent compound. I have already told you, I have already made you understood in your last class, that is ninth class, that what is the difference between ionic and covalent compounds. So you know that ionic compound is a compound that is formed between a metal and a non-metal. When a metal reacts with a non-metal, an ionic compound is formed, but when only non-metals react with each other, they form a covalent compound. You know about it. So here our main topic is how do metals and non-metals react and how are ionic compounds formed. So I will discuss it. So before discussing the reaction between metals and non-metals, let me tell you some points about the bond. What is the thing that holds the elements together? So that thing is called as bond. So bond is the force of attraction that holds the chemical substances together. So when there are two types of compounds, ionic compounds and covalent compounds. So ionic compounds possess ionic bond and covalent compounds possess covalent bond. What is ionic bond? The chemical bond formed by the transfer of electrons from one atom to another. When electrons are transferred from one element to another element, that bond is created between them and the bond is called as ionic bond. It is a chemical bond between oppositely charged ions, because you know that in last class I discussed the formation of cation and anion. That is, for example, A positive, it is a cation, and B negative, it is an anion. The bond created between them, for example, when A positive it reacts with B negative, they form AB, and the bond between A and B is called as ionic bond. Why is it called ionic bond? Because this bond is created between two ions, A positive, which is a cation, and B negative, which is an anion. So it is an ionic bond, and it is formed by the transfer of electrons. When A loses electron in this way, here the first point is metals. So ionic bond is formed between metal and non-metal. Among them, one element loses electron. So electron is lost by metals. metals minus electron and it forms cation. A, for example, it is a metal minus electron, it has lost an electron and it gets converted into A positive, which is a cation. Hence you know that the cation is formed by the loss of electron. The electrons may be 1, 2 or 3. So metals, why do metals lose electrons? In order to become stable, they need to achieve the nearest noble gas configuration. In the same way, non-metals, they gain electron. Which electron they gain? The electron that is lost by metals is gained by the non-metal. B, for instance, it is a non-metal, it gains electron and it gets converted into B negative, which is an anion, and it is formed by the gain of electron. The electrons may be 1, 2 or 3. So metals lose 1, 2 or 3 electrons. In the same way, non-metals gain 1, 2 or 3 electrons. So here you will note down the important points that metals and non-metals do not react directly with each other. They react after the transfer of electron. When electrons are transferred from metals to non-metals, then the ions react, that is cation and anion react with each other and they form an ionic compound. Why is it called ionic compound? Because it is formed by the reaction between ions, between cation and anion. So they are connected by ionic bond. Now I will show you some examples by which the ions are formed and how electrons are transferred and how cation and anions react with each other and form ionic compounds. So here you will note down some important points that an ionic bond is formed when one of the atoms, and that is a metal, donate electron to achieve the inert gas electron configuration, and the other atom, that is non-metal, it needs electrons to achieve the inert gas electronic configuration. So both metal as well as non-metal are unstable and both need to require stability. They need to achieve the nearest noble gas configuration. That is why they react with each other. So here these are the important points. First one is this, that metals have usually 1, 2 or 3 electrons in their valence shell, which they donate to become stable. So metals have either 1 electron, and you know that the number of valency depends on their group number, that is group first elements: lithium, sodium, potassium, rubidium, cesium and francium. You know that they have only 1 electron in their valence shell. When they when they lose the electron, they get converted into Li positive, Na positive and K positive. In the same way, group second elements, that is for example beryllium, it is having, I will show you after this, it is having 2 electrons in its valence shell. After losing the 2 electron, it gets converted into Be2 positive. Aluminium, it is having 3 electrons in its valence shell. When it loses the 3 electrons, it becomes Al3 positive. So metals, whether they are group first elements, group second or other group elements, metals are having 1, 2 or 3 electrons in their valence shell. And when they lose these electrons, they get converted into cations, and cations are either monovalent positive, bivalent positive or trivalent positive. In the same way, non-metals have usually 5, 6 or 7 electrons in their valence shell, so they need electrons to become stable. For example, chlorine, it is having 7 valence electron. It needs only 1 electron to become stable, so when it gains that electron, it gets converted into Cl negative. I will show you in the examples that how are metals and non-metals converted into ions, and how the ions react with each other and form ionic compounds. First example is formation of sodium chloride. Formation of sodium chloride. So it is having two elements. First one is sodium, second one is chlorine. Atomic number of sodium is 11 and that of chlorine is 17. So their electronic configuration is 2, 8 and 1, and electronic configuration of chlorine is 2, 8, 7. This is K shell, this is L shell, and this is M shell. Their valence shell is same. Valence shell means outermost shell. It is same M shell. In sodium the number of valence electron is only 1, and in chlorine the number of valence electron is 7. It must contain, M shell must contain how many total electrons? 8 electrons. So here sodium is short of 7 electrons. It needs 7 electrons to become stable, and chlorine needs only 1 electron to become stable. So it is a metal, it will lose electron, and it is non-metal, it will gain electron. In this way sodium, because both the elements need to achieve nearest noble gas configuration, its electronic configuration is 281. It needs 7 electrons, but it is impossible to gain 7 electrons. It can, an element can gain a maximum of only 3 electrons. In the same way an element can lose a maximum of 3 electrons. So here it is impossible to gain 7 electrons. Therefore it will lose an electron and it will get converted into Na positive. At first its electronic configuration was 281. Here when it loses this electron, its electronic configuration becomes 28, which is the nearest noble gas configuration of which is the electronic configuration of neon. So it becomes stable, so it gets converted from neutral atom to Na positive to cation. Chlorine, the electron that is lost by sodium, it will be gained by chlorine and it will get converted into Cl negative. Here its electronic configuration was 287, it will become 288. The total number of electrons are 18, which is the electronic configuration of argon. So you will see that Na positive, it is sodium cation, and Cl negative, it is chloride anion. So you will note it down. At first sodium is converted into cation, that is a metal is converted into cation, and chlorine is converted into anion. Now I will show you how the ions react with each other, how electron transfer takes place. Na, it is having only one electron in its valence shell. For example, this is the electron plus or plus. Here is chlorine. How many electrons are present in its valence shell? 7 electrons. 1, 2, 3, 4, 5, 6 and 7. These are the 7 electrons. So electron transfer will take place. This electron will be lost by sodium to chlorine. It will get converted into Na positive and Cl. How many electrons will be present in the valence shell of chlorine? 8, and it will be having a negative charge. You will write it in this way, or NaCl. This is the way, but this is electron transfer. Here electron transfer will take place from a metal to a non-metal. So you will remember it that in an ionic compound, metal will always lose electron and non-metal will always gain electron. So this is the way by which electron transfer takes place from a metal and a non-metal. So it is ionic compound. Sodium chloride contains an ionic bond, or they are linked by electrostatic force of attraction, which is the strongest force of attraction between atoms. This is the formation of NaCl. In the same way, formation of KCl takes place. You will practice it. Now I will show you second example, formation of magnesium chloride. Formation of MgCl2. So here magnesium and chlorine. Atomic number of magnesium is 12 and that of chlorine is 17. Its electronic configuration is 2, 8 and 2. Chlorine, you know, its electronic configuration is 2, 8 and 7. Kl and M shell. So this is their valence shell. Magnesium contains 2 electrons in its valence shell and chlorine contains 7 electrons in its valence shell. Magnesium is short of 6 electrons and chlorine is short of only 1 electron. So here you will note it down that magnesium will lose 2 electrons. Magnesium, it will lose, it contains 2 electrons in its valence shell, so it will lose these 2 electrons and it will get converted into Mg2 positive. Chlorine is having 7 electrons in its valence shell. It will gain how many electrons? It will gain 1 electron to get converted into Cl negative. But here magnesium will lose 2 electrons and chlorine needs only 1 electron. So the electrons lost by the metal will be directly proportional to the number of chloride ions. That is, when magnesium loses 2 electrons, it reacts with 2 atoms of chlorine. So 2 atoms of chlorine will gain 2 electrons and it will get converted into 2Cl negative, because magnesium will lose 2 electrons and the non-metal must gain the 2 electron, but here chlorine needs only 1 electron. So in order to balance this ionic reaction, the number of chlorine atoms that will react with the magnesium will be 2. So this is the way by which magnesium and chlorine will lose electrons. I will show you the mechanism by which they will magnesium will transfer its 2 electrons to the 2 chlorine atoms. This is magnesium. It is having 2 valence electrons. It will react with how many chlorine atoms? 2 chlorine atoms. Each chlorine atom contains 7 electrons in its valence shell. So here 1 electron will be gained by 1 chlorine atom and second electron will be gained by second chlorine atom. This is the electron transfer, and it will get converted into Mg2 positive and twice Cl negative, and then the magnesium and chlorine will react with each other and they will form MgCl2. This is the formation of second compound, that is magnesium oxide, magnesium chloride. Now I will show you a last example. That is magnesium oxide. So you will solve it in the same way, whether you are solving it in your examination or you are solving it at your home. You will follow the same procedure. Magnesium and oxygen, atomic number of magnesium is 12 and that of oxygen is 8. Electronic configuration is 2, 8 and 2. Its electronic configuration is 2 and 6. K shell, L shell and M shell. So the valence shell of magnesium is M and that of oxygen is L. M as well as L shell must possess how many electrons? It must contain how many electrons? Maximum of 8 electrons. So here magnesium needs 6 electrons to become stable and oxygen needs only 2 electrons to become stable. But magnesium is a metal, it will lose electron, and oxygen is a non-metal, it will gain electron. Transfer of electron will take place in this way. Magnesium minus electron, how many electrons? 2 electrons. It will get converted into Mg2 positive, magnesium divalent positive ion, and oxygen, it will gain 2 electrons because it needs 2 electrons to become stable. It will get converted into oxygen 2 negative. Here its electronic configuration was 2 6 and here it will become 2 and 8. So in this way they will get converted into magnesium cation and oxygen anion. Now how will electron transfer take place? In this way, magnesium, the number of valence electrons are 2 plus oxygen, the number of valence electrons are 6. It will lose these 2 electrons, electron transfer will take place, it will get converted into Mg2 positive and oxygen 2 negative. Here magnesium will left with how many electrons? 10 electrons, which is the noble gas configuration of neon. At first it was having 12 electrons and now it will be left with 10 electrons, which is the nearest noble gas configuration of helium. So in this way it will become MgO, magnesium oxide. And you also know about the chemical formula. I have discussed it in your 9th class. So this is the formation of magnesium oxide. So these were some examples by which ionic compounds are formed. In my next class, I will give you some information about covalent bond and covalent compounds.